Hello, good morning. Welcome to the Stencyl Games course preview. My name is Zeke, and I'm a lecturer at the local university, the Asia Pacific University of Innovation and Technology, and I teach the computer games course. I teach the games design, level design, game programming, and also several other courses that are part of the games course there. Now, welcome to the preview, and I hope you can hear me loud and clear wherever you are in the world. So what's going to happen today? I'll just go over the PowerPoint and we'll just have a look and see what's going to happen. All right, you should be able to see my screen now. Here's an overview of what we'll be covering today. So firstly, what is Stencyl? We'll talk a bit about what is Stencyl. I won't go into the full details. You can find the details at the website stencyl.com. Some examples of games made with Stencyl. The course overview. We'll talk a bit about the common game development process and the software tools that I personally use, as well as the process that I teach at the university. Also, I'll be including a mini game live demo where I'll show you how Stencyl can be used to create a simple game. And at the end of the session, we'll have a Q&A. I welcome questions and answers. Probably we'll just post up some comments in the events page, and feel free to leave a comment there so that I can have a look at it. I'll also bring up a couple of common questions that we'll answer at the end of the preview. Okay, so what is Stencyl? Stencyl is a game development software that enables anyone, just about anyone, to create cross-platform games without any code. Current supported platforms for Stencyl include Flash, iOS, both for the iPhone and iPad, Windows, and Mac. And soon to be released 3.0, it will support HTML5 and Android. These stats were taken off the website. You'll see that they have more than 120,000 developers with more than 12,000 over games developed. So why use Stencyl? Well, firstly, you'll find that Stencyl is a software that allows you to rapidly build proof of concept prototypes. You can easily put together a very simple game or prototype in a matter of days or even hours. You'll be able to see your results immediately as you build your game. And you have a visual interface that enables you to create simple or complex games. Other reasons includes Stencyl has the functionality that has built-in physics, sprite management, animation, collision detection, sounds, and many other features, including screen management as well. It enables you to create behaviors and game mechanics with much ease, as they use a simple drag and drop interface to add logic blocks to your behaviors. And naturally, Stencyl does not require you to have any prior knowledge of any programming language. So it's perfectly suitable for anyone who wants to get started making their own games, especially if they have zero programming knowledge or zero game development experience. Now here are some examples of games made with Stencyl. So two games here hit the top charts, created in Stencyl and published in the Apple App Store. The first on the left is Impossible Pixel. You can check it out on the App Store, as well as Blip. Here are some other games made with Stencyl. We have Skull Face on the top left. We have Making Monkeys on the bottom left. We have Tiny Tomb Robber, Neocon Tower Defense, as well as Captain Steel Bounce. Now these are some games that are already published, and you can actually check it out at the Stencyl website in the showcase section. Okay, so what's coming up with the games course? Here's an overview of what's going to happen. Firstly, what's the goal and objective of having the games course? Now, unlike other games courses that you might take or you might have seen online, the goal of this is to teach you how to make your own games. The point is not for you to just merely complete the tutorial sessions, but to also bring your own ideas. The session will be run such that at the end of each weekly session, each participant will be given an assignment. The assignment is meant for you to come up with your own ideas using what you've learned during that session so that you can create your own ideas using the tools and the mechanics that we've talked about during a session, and share your ideas with the private community that is already set up. So what's going to happen is I'm going to encourage everyone who participates to actually come up with their own ideas, and throughout the duration of the 8-week course, you should be able to create your own unique ideas using the mechanics that we learned in the 2 games we will create. So who is this course for? It's for absolute beginners with little to no programming knowledge. Now I'm aiming at absolute beginners because there are a number of people who actually have requested to learn about this course or to learn how to use Stencyl, but they have trouble just getting started. It takes a while just to get started to create your own games. From my own experience, it actually took me a couple of weeks to actually get started just trying to create my own game after figuring out how the software actually works. And it's also for those who aspire to be game developers. Anyone can be game developers, from school children up to high school, even college students. So here's a brief outline of the modules that will be covered. Module 1 includes getting started. Module 2 is where we'll start game number 1. And Module 3 is game number 2. And here is a breakdown of the weeks that we'll be covering. So in week 1, we'll have the introduction. We'll go over the whole course overview, the goals and objectives of this course, the roadmap, and we'll start on our first game. So game number 1, item drop. We'll go over the whole project and project overview, the goals and objectives of this project, the game entities or objects or actors that we'll be including in the project, the game mechanics and controls, some basic level design, as well as the look and feel of the game. Week 2. Week 2 we'll be talking about the Stencyl environment, how to set up a new project, creating new scenes. Scenes are basically different pages or screens. What are actors? Importing artwork and sounds. During the course, the artwork and sounds will be provided. Of course, those who participate will be encouraged to come up with their own artwork and sounds. I will be also sharing my own links where you can get open source artwork so that you don't have to create it if you're not an artist. And we'll create one level design for our game. So we'll also be starting with creating the game, learning how to add items dynamically, refining some physics properties, as well as learning to create some reusable and robust behaviors. Behaviors are one of the strengths of Stencyl. It allows you to reuse functionality and code without having you to apply it manually each time you need to create or reuse the same functionality. In week 3, we'll be learning how to create your characters, adding user controls, animation states, making your character jump, and also starting out with basic collision detection. You learn how to communicate between actors, how to destroy an actor, as well as learning about events. In week 4, we'll cover scene behaviors, how to add actors to a scene. We'll learn about timers and intervals, variable range values to come up with a random range of values, for example, between the values of 0 and 100. How do we get a random value between that range? We'll learn how to trigger certain behaviors using events. We'll also learn about global variables, which allows you to keep score as well as keeping track of time during your game. And finally, adding text. So the first 4 weeks will be covering the first game, the item drop game, and the last 4 weeks will be covering the second game. So in week 5, we'll be starting the second game. It's going to be an Asteroids clone. So we go over the project, goals and objectives, the game entities and objects, mechanics and controls, and we'll get started with the project, importing artwork and sounds. Again, the artwork and the sound effects will be provided. The game scene setup, and we'll start week 5 with adding your player ship. So how do you add it to the scene? Moving your ship around, moving forward, and also again converting logic into reusable behaviors. Week 6 will cover shooting. So this is when we'll allow our player to be able to shoot. So we're going to create bullets, allow the bullets to shoot in a certain direction and a certain speed. We'll cover aiming, and we'll also cover game boundaries. If any of you have played any form of Asteroids clone, you'll find that we have what is known as a one-screen universe, where we limit the actor's movement so that it's impossible for the actor to completely leave the screen. What will happen is the moment the actor leaves the screen, it will come out on the opposite end of the screen. We create a single screen universe, and we'll also apply these game boundaries to the bullets as well. So you'll find that when you shoot outside of the screen, it comes back out on the opposite end. Week 7. In week 7, we'll start creating asteroids, learning how to move an asteroid, spawning asteroids randomly from 4 sides of the screen, destroying an asteroid, as well as dealing with the individual asteroid pieces. So how do we spawn smaller asteroids from the ones that are destroyed? That's the topic we'll cover. And we'll spawn even smaller ones once the medium-sized asteroids are destroyed. And finally, once the small asteroids are completely destroyed. Week 8. Week 8 is adding the final touches. We're going to add a health bar, add scores, and also add a game menu. So we'll have a game menu scene, a game over scene. Alright, so that covers the 8 weeks of the course. Okay, so what's next? Now I'm going to show you a simple demo of the game. First, we'll have a look at the item drop game. Okay, give me a minute while I open up the game. Alright, here's a screenshot of the game. Okay, I know it's a little, the video's lagging a little bit. Okay, so here's a screenshot of the game. You have your character moving around the screen, collecting items, coins as it drops, and you'll also have bombs dropping down from the top of the screen. So as a player, you need to avoid the bombs as well as collect the coins before dying. That's the first game. Now here's the second game. This is what we'll create. We'll be creating an asteroids. Okay, let me just share my screen with you. Right, this is what we'll be creating. We'll be creating an asteroids clone. You'll have your player ship right in the middle of the screen. And you'll be able to fire. And of course, it looks a little ridiculous with so many asteroids. But we can always adjust that during the game, and we'll cover some fine-tuning. So you have your player ship running, flying in the middle of the screen, and you have asteroids appearing at various sides of the screen. Okay, so those are the two game demos that we'll be covering during the workshop, during the course. And the 8 weeks course, my hope is that as we complete each game tutorial, you'll be able to create similar games from the ones that you've learned. All right, so how much is this going to cost? Right, how much is this going to cost? So the registration for the course, now typically it costs $499 for the 8 weeks, $499. But for a special preview promo, I'm offering the course at $299 for the 8 weeks. So if you are interested in signing up for the course, you can check out my website, www.zchan.com/special-preview. There's a link on the site that will bring you to the PayPal checkout page, and the start date for this course is going to be on the 7th of June. Right, as mentioned earlier on in the beginning of the preview, I'm going to just briefly share the game development process as well as the tools that I commonly use in creating games. So I usually start off with a rapid prototype. So there are 3 steps involved. First, creating a mock-up and a game prototype. Sometimes this is done on paper so that I have an idea of what I'm trying to build. It is usually going to be a one screen or one level game. Step 2 involves creating complete game mechanics. So the basic game mechanics that the game should have are all included in step 2. And finally, in step 3, this is where I test, do my debugging, as well as get feedback from my peers, friends, and whoever else will be interested to try it out. After those 3 steps, and if I'm happy with the results, then I move on to the next 3 steps. So I start by adding extra features to the game, build levels, and once again, after all the levels are complete, go through a phase of testing, debugging, as well as receiving even more feedback. So this is the standard game development process that I also teach at the university. These are the game tools that I actually use. So for graphics, commonly I use Adobe Fireworks. For animation, I use Flash CS6. Reason why my choice of Flash CS6 is because you can create animations and preview it before actually exporting it into sprite sheets, which is basically what Stencyl uses to create its own animation. For programming, I usually use Flash Develop. And for compilation, I use the Stencyl software. Now at times I also use Flash CS6, but usually I use Stencyl. Okay, here's where we come to the mini game live demo. I'm just going to show you how easy it is to use Stencyl to actually set up a game, and we're going to create a very simple game. Okay, here we have our list of games. This is what you see when you launch Stencyl. So I'm going to create a game from scratch just to demonstrate the ease of use of creating Stencyl. So we'll create a blank game starting from scratch. I'll call it the Stencyl game preview demo. And we're going to run at 640 by 480 screen resolution. So here we have our empty scene. So we currently don't have any scenes or any screens in our game. I'll start off by creating a game scene. Okay, here's my blank game scene. At the moment, there isn't anything inside. So what I need to do is I need to import all of the assets or the actors. I'll start by importing the tile set. Okay, if you can see my screen, you'll see 2 sound effects. One is sound effect and one background music file. And you see a list of the sprites that I will use for this game demo. After importing the tile sheet, this is what it looks like. So I'm just going to add this to my game. Alright, so I have a list of the tiles that I'll be using in my game. Now each of these tiles by default are given a square collision, meaning that your character cannot walk across the tile, so it will block the character. We'll change that once we design our game scene. Next, I'm going to import the actors that I will be using in this game. I'll start with the player. Right, the player contains no animations, so I'm going to add some animations into this. I'll start with move down. Okay, as you can see, there is a preview of the sprite sheet, and what I need to do is I just need to tell how many sprites are within this sprite sheet. So I have 4 columns and 4 rows. Now one of the wonderful things about Stencyl is once you import a sprite sheet, you can actually see the animation preview on the left side of the screen. As you can see here, my animation 0, I can see my character walking. So this allows me to actually see if the animation looks right. I'm going to import all the other animations. I will call this animation down, walk. Right, let's add some more animation states into this. Here we have our left walking animation. Our right walking animation. And finally, we will have our up walking animation. Okay, so we have all of our animation states in this. Now we're only missing a couple more states. By default, Stencyl will choose the first animation state as the default state. However, we normally won't use an animation like this because our character will start walking downwards if we leave this as the default. So, for example, I'll just add this in and you can have a look at that. So here's my player. I'm just going to add it somewhere on the screen. If I leave this as a default, basically what happens is my player will be walking as a default. Okay, I'm not sure if you can see that. All right, I'll just get back to the demo. So by default, what happens is okay, let me just right, by default what happens is each animation state will require a separate set of animations. So for example, if my walking animation, I need to have an idle state. So rather than importing the whole sprite sheet again, what I would normally do is, since I'm reusing the sprites, I will just duplicate the animation state and choose one frame for the idle state. So for example, for this downwalk animation, I'll hit the duplicate button. So I have a copy here, and I'll just rename that first. So I'll call it down idle. Then I will delete the unwanted animation frames so that I have one frame left. If you look at my preview panel on the left, you will see now that my down idle does not have animation simply because it has only one state. Now, if you notice that there's this star icon right next to the animation state, so the star icon is the default state that the actor starts with. So I'm just going to set the down idle as my default state. Now I'm quickly going to duplicate the other states. One final state to duplicate. Alright, so I have in total 8 animation states. My 8 animation states, up, down, left, right, have got both walking as well as the idle state. Okay, I'm going to import one more actor. I'm going to call this star. The point of the game is that we are basically going to collect stars. So I'm going to create that actor. Okay, here I have my star, and it's going to be used later on in the game. Okay, so I have two animation states, sorry, two actor types. I have one scene as well as one tile set. I'm also going to import the sounds. So I will first call the collect sound. All right, this is a sound effect. That's what it sounds like. Then I'm going to import the music, background music. All right, that's what it sounds like. Okay, and I'm going to save the entire project. Okay, I have all my assets. Now the first thing I'm going to do is I'm going to create my level 1. So my level 1, I'm going to fill it with grass, and I'm going to put boundaries on the side. Okay, that's what my level 1 looks like. All right, now the only problem with using the default tiles sheet is all the tiles are set to have a square block as its physics collision. So what I'll need to do is I'll need to disable the physics for the green tiles so that my character is able to freely walk within that tile sheet. So I'm going to open up my tile set again, select the green tile that I used in the design, and with my collision bounds here, I'm going to set it to no collision. So this will allow my character to walk around the map freely. So I'm going to set that to no collision and save my game. Okay, so here we have our character. So what's next? Now the first thing we need to do is we just want our character to move around. So I'm going to add some behaviors for my actor, my player actor. Right, here I am in my player. This is my player actor. And I'm going to go into the events, okay, the events tab. And this is what it looks like. So I have my palette on the right, which will allow me to just drag and drop, right? Drag and drop any form of code logic or code block to form the behaviors of the character. The first thing I'll start with is adding a basic event. So we have a couple of basic events. For example, the first event is when the actor is created. Secondly, when it is updating its render or when it's drawing. And third is every game loop or every frame update. So I'm going to use the when updating event. So this will always run as long as the game is running. All right, first off, I'm going to add the conditions to check and see which key I'm pressing at the current time. So I will start with adding the key presses. So I have my if condition, and I'm selecting a control that starts with left. I'm going to start with my left control button. So I have if the left key is being pressed, okay, and I'll form the code later on. Now I'm going to add the others as well. So I have 4 directions, and I'm going to add an otherwise if, this otherwise if condition if my left key is not being pressed. So I'll start with left. Right. Up, and finally down. Okay, so I have 4 conditions set to detect which key I'm being pressed. If you notice, I have an otherwise if. What happens is I'm only going to allow the player to move in one direction. So it can only move either in up, down, left, or right. The player is not allowed to move diagonally across in any direction. So here I have my left key. Now I'm just going to set this movement of the character. So in my actor palette, I have the X speed of the character. So I'm going to set the speed of the character here. I'm just going to throw in a number of, let's say, -10. So when I press the left key, my character will move -10. Okay, let me just test that out and see if you can see that preview. All right, here is my preview of the game. So I've only set for the left key to -10 for the X speed. So you'll have your character moving towards the left. You notice my character didn't stop. That's because I have not set any state to stop the character from moving. I'll fill in the speed for the other directions right now. I'm setting my X speed for the right direction. Also my up and down. So I have Y speed for the up and down. Okay, so here I have the speed for all the directions, up, down, left, and right. I'm going to test it out again. Right, here's my character. I'm going to move the character in all directions. So you can now move left, right, up, as well as down. Right, if you notice, we are moving in diagonal directions. Right, that's because we haven't stopped the character from moving the moment we release a key. So it shouldn't be able to do this actually. Okay, back to the screencast. Okay, so I have my 4 directional speeds. What I'm going to set is I need to disable the diagonal movement. So whenever I'm pressing any of the vertical keys or the horizontal keys, I need to make sure I disable the other directions. For example, okay, for example, uh, for my left key, when I'm moving left and right, I need to disable the vertical, the up and down. So what I will do is I am setting the Y speed, right? I'm setting it to 0 so that it stops moving vertically when I'm moving left. Now, likewise, I can also, I'm going to duplicate the code here. I'm going to put that in, right? I'm going to paste another 2 for the X. So when I'm moving up and down in the vertical directions, I'm going to disable both horizontal directions. So here is my up, down, left, and right. Okay, let me just test that out. I'm going to switch screens to my Flash preview. Okay, I hope you can see that preview. So here I have the screenshot of the game. And right now, if I try to move in either direction, we no longer have that problem of diagonal movement. Right, so now our character is able to move in the right directions in the way that we want it to. Okay, so what's next? Now, I need to stop the animation from moving, the actor from moving. So I'm going to add one more conditional at the end. I'm going to say otherwise. Otherwise, meaning if I'm not pressing the up, down, left, right, otherwise I will perform something else. So here's what's going to happen. I'm going to set both my X and Y speed to 0. Right, I have my X and Y speed to 0. This will basically stop my character if I'm not pressing any of the keys. Okay, let's go full screen so you can see everything that's happening. Okay, I hope you can see that. Here is the preview for the current state. So our character can now move in 4 directions, up, down, left, and right. And it can now stop. So our character is now able to stop and no longer move. So that's what we have. Okay, now let's work on the next part of the actor. If you notice, our actor is not showing any of the animation states. It's only using the default state currently. So let's add that in. Now there's one thing that I want to change with the value of the speed here. Normally when I have common values, in this case I have a common speed of 10, I will create an attribute or what is known as a variable so that it stores the speed and has a default value that I can easily change. So I'm just going to call this move speed, right? The type is a number. And I can change the default value of the move speed to here, 10. I'm going to set that default value to 10. And I'm just going to replace all of these speed values with my move speed attribute. Okay, notice that for my left and my up direction, the value is -10. So there would be a problem if I just leave the move speed at its default because it's a positive value. So there's no way it's going to be able to move left or move up. So there is a code block here called negate, which basically turns the value into a negative. So I'm going to add that in, negative, and move speed. I'm going to add the current move speed to all of the code. So for my up, I'm going to use the negate again and add the negative move speed there. Okay, let me just test it again to see if it works. Ah, great, it works. So now we have our character moving in all 4 directions, and we are using a move speed of 10. Now, one of the wonderful things about creating an attribute is that it's very easy to change the move speed, and you don't have to change any of the code blocks here. For instance, if let's say I change the move speed and I set a default value of, for example, I'm going to increase the speed to 20. So I set my default speed to 20, and immediately it's reflected in my game. So you should be able to see the character moving at a speed of 20 pixels per frame. Once again, if you're not happy with the speed, I'm going to reduce that to 5. So here I have the character moving at 5 pixels per frame. And easily, I don't have to change any of the code blocks or logic behind it. So attributes are actually a wonderful thing. And if you've actually made games, you'll find that it's a very useful part of games. All right, I'm going to reset the speed back to the default value of 10. Now let's take care of the animation states. So how do we switch states? Right, if you see in the actor palette, there is a switch animation tools block here. I'm just going to add the as animation anything. So this will allow me to choose which animation state. Now here's one way that we can do it. If you look at the list of animation states on my left, you'll see down idle, down walk, left idle, left walk, and so on. So these are the name of the states of animation that we will be using for our game. Now keep track of the name. For example, let's say I will have down idle, down walk, left idle, left walk. Let me just try and add the animation for the walking movements. So I'm going to start with down walk. That's my default animation state for moving down. I'm going to copy that and repeat it 3 times. Okay, of course, I need to rename the animation state for each direction. So I have my left walk, right walk, up walk, and down walk. Let me just test this out. Okay, you will notice that once I start moving, the animation state does not reset itself because we have not yet done that. Okay, so now my character moves in the direction with the correct animation state playing. So when I'm moving, it changes animation state to the direction I'm moving. So I have my character moving up, down, left, and right. Right, notice that the animation doesn't stop or reset back to the idle state because I've not added that in. All right, one of the things that I have learned when I was picking up Stencyl is that there is an easier way to actually switch animation states rather than manually coding in or typing in the name of the animation state. So if you notice that whenever there's a repeat in code blocks, what I always try to do is I try to refactor my code or my blocks so that I reduce the number of blocks required for this to run. In this case, I have 4 blocks of animation states, and I'm trying to see if I can reduce that to 1 state. So what I'm going to do is I'm just going to get rid of all the states, the animation states, and just put it right at the end. Switch animation to, as well as choosing the animation state. Right, so I am going to add another 2 attributes in, just to cater to the animation state. So I'm going to create 2 new attributes. The first will be the action. The current action of the character, we only have 2 right now, either walk or idle. So the action attribute will be a type of text. Okay, and I'm going to create another attribute called direction, also text. Okay, and I'm going to set some default values for this. So for example, my default text, okay, let me just open up the attributes. I'm going to set my default value for action. Okay, hang on, this is direction. I'm going to set the default to down. And for action, my default value is going to be idle. So by default, the actor is supposed to be idle, and the direction is supposed to face is down. So I'm going to just test this out and see if it works. Here I'm going to replace my hard-coded value of down walk. I'm going to set a text there. So I will set first of all the direction and then the action. Look at the code block, it says direction plus action. Basically what happens is it's going to combine the 2 text to make up 1 text field. So if you're moving down and we're walking, it will say direction down plus walk. So we have the down walk state. All right, I'm going to set up my default action now. So I'm going to say, okay, I'm going to set some attributes. When I enter my frame loop, the action is going to set to walk. And I'm going to set the direction for each of my key presses. So for example, left. Left, right, up and down. So I have my 4 directions. I have left, right, up, and down. By default, we are walking. Okay, the moment the frame loop starts or the update loop starts, it starts with the walk animation. And I'm going to set, okay, I'm going to set the idle state now. So copy this, change this to idle, and the idle occurs when we are not pressing any of the keys. So my action is set to idle in the otherwise code block. All right, so let's test this out and see if it works. Here I have my preview again. So I'm going to walk left, walk right, up, and down. So now we have our character walking up, down, left, and right. And our character can stop at the idle state. So this is what it currently looks like. All right, so our player is done. Okay, there are a couple more things that I'm going to deal with the player before I move on to the next. So first of all, I'm going to check the physics tab. So a couple of things I need to change here. First of all, this is the physics tab, and there are three basic properties that we can change. So first of all, the type of actor, I'm just going to leave that at normal. My actor here, it says by default, can my actor rotate? I'm going to set it to no. I'm not going to allow it to rotate. And there's also not going to be any gravity, so I'm going to set the gravity to no. All right, that's the only other setting that I need to change to get this to work. So I'm going to save my game. And now I'm going to move on to the next actor, which is the star. So what I'm going to do is I'm going to now make the star appear on the screen. I'm going back into my game scene and looking at the events. So here is where we try and create stars on the screen. What I'm going to do is we're going to start by adding an when created event. So this event triggers when the scene is ready, when it's about to appear. The when created event triggers. So I'm just going to start by seeing if I can make my star appear on the screen. Right, in my scene, I have this create actor type. So I'm going to choose my star. Just throw it somewhere in the middle of the screen, 300 by 300. Let's just test it out. Okay, there we have it. So we have a star there on the screen. There's no code added to it. Also notice that the physics is applied, so it does continually move in one direction and it can rotate. Right? If you noticed earlier on, it did rotate after a while. So I can push my star and I can actually rotate it. Okay, we'll work on the physics in a short bit. So let's just work on getting the stars onto the screen. So we can see on my screen when the scene is created, the first thing that we do is we create a new star. Now in Stencyl, they have the ability to also add in custom events. So for example, here's what I'm going to do. I'm going to have an event triggered to create the star. So what I will do is I will have an advanced. I'm going to add an advanced event, and here I choose a custom event. So custom event, I'm just going to rename that to create star. Right, that's my create star event. And I need to set the name or the trigger for it. So I'm going to call it create star. Okay. So when create star happens, okay, when this event is triggered, then there will be a series of code blocks happening there. So I'm going to move this code block out of the when created and place that in the create star event. Okay, let's see if that works. I'm going to go back into my created event. So I'm going to trigger the create star event. So trigger event create star in all behaviors for this scene. Let's try that and see if it works. All right, it works. So our custom event is working. Now just to add on more code so that it doesn't always appear at that same location. So what I'm going to do is I want my star to appear randomly on the screen. So it's going to appear at every single place on the screen. And I'm going to use random attributes from the number block. Okay, so I'm going to choose a random number between. Okay, for the X, let's first look at the properties. In order for us to define how we should do this, we need to take note of the size of the tile. So one tile, if you look at the scene properties, is 32 pixels. The width and the height are both 32 pixels. So I'm going to use that as a base. Basically, what's going to happen is I'm just going to pick a random row and a random column for my star to appear at. So here's what I'm going to do. I'm going to say math multiplier. All right, I'm going to put tile size is 32 and random number between 1 and 18. And now why the numbers 1 and 18, if you look at my scene properties, I actually have, right, 20 by 15. So what's going to happen is it's going to appear between 1 and 18. So my first column to my second last column. So that's where it's going to appear. Okay, I'm going to just drag that in. I'm going to repeat that for the Y as well. The Y is the rows. So my rows are only 13. Right? If you look at the properties, I have a height of 15 tiles. So basically, I'm just going to minus 2 for the top and bottom, and I have 13. Okay, so I have a random column, random row selected. Let's try that out. Okay, here it is, star appearing here. Let's try it again and see if it works. All right, so we have our star appearing randomly somewhere on the map. So every time you run the game, the star should appear at a random location. Okay. So what's next? Now that we have our star appearing, we want more stars to appear after a certain period of time. So what I'm going to do is I'm going to set a time. Okay, I'm going to create, first of all, create an attribute. An attribute, let's call it next interval. Okay, next interval will be a number. Okay, so we have an attribute called next interval, which basically is a number. But there are no default values for this since we will always be setting it. So I'm just going to throw that into my scene. Right. The moment a star is created, we are basically going to set a minimum and random range for the time when the next star will appear. So we have a minimum time as well as a maximum time range for the next star to appear. And I'm going to add 2 more attributes. Let me call it interval. Okay, interval minimum. The type is number. I'm going to call it interval max for the maximum time range, also number. Okay, and I'm going to set a range of, let's see, 0.5. Okay, the first star should, the minimum time, oops, this is the maximum. Okay, minimum time should be 0.5. And I'm going to set the maximum time to, let's say, 2 seconds. So my maximum time here will be 2 seconds. Okay, so I have a minimum time of 0.5 here and a maximum time of 2. So that's the range of time that's going to happen. All right, my next interval. So there is of course, there is a formula for creating a random range of values. So I'm going to start by saying that, okay, I'm going to have a random range between the minimum value, right, plus a certain range. I'm going to use a random floating number between 0 and 1. So what happens is we'll get a floating number. It could be 0.1, 0.234, 0.9, and so on. So we have a random value there. Okay, and now I'm going to add the range maximum minus the minimum. Okay, so I have the next interval attribute set. And every time you run this, we'll be able to see a random range appearing. So the time range is between 0.5 and 2 seconds when each star will appear. Let's add one final code block. So I'm going to use a time code block called do after. So do after attribute will be next interval. So do after next interval, that's the random time that we set previously. And what's going to happen is I'm just going to trigger the same event. I'm copying this code block, pasting it here, and here we have trigger event create star in all behaviors for this scene. So I'm going to run this, and we should have a star appearing every 0.5 to 2 seconds. Right, if you can see my scene, there's a star appearing every 0.5 to 2 seconds. Great, it's working. Okay, now let's go back to the star, remove some of the physics, and allow our star to be collected. Here's my star actor, and I'm looking at the collision tab now. By default, our star will react to any physical collision, to any physics collision. So what I want is I don't want the star to react immediately to the collision. As by default, it will still detect the collision, but there's an option here that says sensor. Is it the sensor? Which will basically allow you to detect collisions without responding to it. So our star, by checking this option, our star will not be a solid object and will not be able to be pushed around. I'm also going to set the physics property here. What kind of actor type? I'm going to set no, it cannot move. Our actor won't be able to rotate or be affected by gravity. Okay, let's go to the events tab now. I'm going to add a collision. So if any actor collides with this, I'm going to add this event. So when we are colliding with a specific character or specific actor, something happens. So here we have the event for the actor type. When self refers to the star, when self hits actor type, I'm just going to choose that. So when it hits the player, right? When it hits the player, what happens? So first, let's say I'm just going to set one code block and kill self. All right, so the moment our collision occurs, our star disappears. So we actually use the kill code block to make an actor disappear from the scene. Okay, that works. Right, basically that works. Now we are trying to add a couple more things to this. Our game is still not quite complete. So what I'm going to do is I'm going to add two more things. First of all, I'm going to add some global attributes, the score as well as the timer. And secondly, I'm going to add a timer bar as well as a score counter onto the scene. So first, let me add the score counter. Now, when it comes to using text in Stencyl, they have this fonts option, and I'm going to add a game font in. So let me just call it score. Right here is a preview of what it looks like. I'm going to set the font, let's say, to typewriter. Font style bold. Smoothing, yes. I think I'll set my color to white. Right, some effects. If I just leave it as white, it doesn't really stand out. So I'm going to set a stroke color of gray. Okay, that seems to look right. All right, I'm going to set the shadow as well. So a 1 pixel shadow. And my text should look something like this. This is a preview of the text. And I will save my game. All right, let's try and add the text into the scene. I'm going to go into the events again. So now I'm going to add a new event called drawing. It's under the basics option when drawing. And I'm going to choose my font. So first of all, I'm going to choose a style. So set font, current font, and I'm going to choose the font. Okay, before we continue on, I'm just going to take a minute break and I'll be right back. Okay, I'm back. So we stopped off at the font. The first thing I'm going to do is I have set the current font to score. I'm going to choose my font color. Let's say I'm going to choose a white. Okay, let's choose white. And I'm going to draw text on the screen. So drawing. Draw text, anything on the screen. Okay, first let me just add in score. Right, I'm going to put the word score there, somewhere at let's say 500. All right, so we have our score at the top right of the screen, as you can see. Yeah, I'm going to just change the score a bit. Something, it doesn't look quite right. Okay, so we have our score there. At the top right, we can see the word score, and we have. Okay, we now need to add an attribute in order for us to change the value of the text. So I'm going to add some attributes now, two global attributes. Under the attributes palette, there's the game attributes, and I'm going to create two game attributes. So what's the first attribute going to be called? I'm going to call it score, and the type is number by default. I'm going to create another attribute called time. Okay, this is for my time counter, time left. Okay, it's also a number. Time increment. Right, this is more for later on when I want to draw my timer bar. I'm also going to create one more called maximum time. Okay, so here I have 4 attributes. Maximum time means how long do I have to play this game. The score keeps track of my score, as well as the time attributes here, where we will use to create our timer bar. All right, I'm going to hit that. So now I'm going to change this. My default score will be 0. So this text here is no longer applicable. I need to use another text. Okay, here's a text code block. So I'm going to put score in here. And the attribute is a number type, so I need to convert that number into a text. So I'm going to drag the score in. All right, let's just see if that number appears. All right, so we have score and the number 0 appearing. So our global score attribute is working. Let's try and change that value now. Going back to the star again, I'm going to change that global attribute. So I'm going to set score. Set score, and I'm going to say, okay, score is going to be, let's put this at score plus 1. Okay, let's just try that out and see if that works. Okay, so when I collect a star, it should increase my score by 1. Right, it works. So as I'm collecting stars, okay, my score increases by 1. Okay, we've got the score counter working. So what's next? I want to add in a timer bar so that the game doesn't run endlessly. And I'm going to add it into my game scene. So what I'm going to do is I'm just going to try and draw a timer bar on the top using the drawing palette again. All right, let's see. Let's set the stroke color first. So I'm going to set the stroke color. The stroke color is the outline color basically. Set it at black. Stroke color, right? Stroke thickness, the thickness of the line. Set that to 1. You need to have a minimum thickness of 1 in order for it to appear. And I'm going to set the color of my bar. So let's say I'm set it at red. Okay, so we have the color of my bar to red. Now I'm going to add in a code block, which basically says that, okay, how big am I going to draw this? So after my color is set, I'm going to set it to fill color. So roughly somewhere on the screen, 32 and 10. That's where it's going to be on the screen. And how big is the bar going to be, the width and the height? Okay, normally I would prefer to set a attribute for this rather than hard coding the values in. So I'm going to set create two new attributes. I'm going to call it bar width. So type number and bar height. Okay, now the reason why I'm using attributes, oops, I've set the wrong attribute for that. Okay, bar height should be a number rather than an actor. Okay, number. All right. So my default bar width, I'm going to set it to 200 pixels. My bar height, let's just say I set it to 5. Okay, my default bar height is 5 pixels. And I'm going to drag this into my width and height. Okay, let's see if that works. We should be able to see our bar appearing at the top left. Okay, that's what it looks like. So we now have a bar appearing at the top left of the screen. So it's a red bar. It's not moving yet. We haven't added the behaviors in. Okay, that's fine. Let's try and add in some behaviors now to update our bar. Okay, first off, we have our maximum time. I think I have not set that. So interval minimum, right, it's under the game attributes. I'm going to add in a couple of things here. So let's change the score. When my game scene starts, right, first of all, I want to reset my score. So I'm going to set my score back to 0. I'm also going to set my maximum time. Right, maximum time to 30, let's say 30 seconds. And the time left. So time left will be the maximum time. So by default, our time that's remaining that will affect our timer bar is going to be set to the maximum time. Right, I've not set the default value for the time increment. I'm going to set it to 0.1. This occurs every 0.1 seconds, so our timer bar should tick down every 1/10 of a second. Okay, now I've set my default values of score to 0, maximum time to 30, time left to maximum time. Now I'm going to trigger the event. So first off, I'm going to do after 1 second. Trigger the create star event. So our create star event happens 1 second after our scene appears. I'm going to add a do every within that. So this do every code block will trigger every X or N seconds. So I'm going to use the time increment here. Right, it's set to 0.1. So every 0.1 seconds, the code block within this will run. I'm going to start with checking my time. So if condition, I'm going to add a comparison. If my time left is more than 0, right? If it's more than 0, then I'm going to reduce my time. So I'm going to set my time left minus my time increment. So at every 0.1 second interval, my time attribute will be decreased by 0.1 as well. So I'm going to use that here. So what happens when time runs out? I'm going to add in an otherwise block. If my time left hits 0 or less than 0, I'm going to kill the player, remove the player from the screen. Right, that's my player. And I'm going to fade out. Right, so I'm going to fade out the moment the time's up. I'm going to fade out my scene. Take 1 second to fade out, and 0.5 seconds to fade in. Okay, let's just try that out, see if this works. So after our time runs out, it should basically fade out the scene. Right, it kills the player so we can't move, and it fades out the scene and reloads the scene. Okay, we have our timer bar here. Okay, our time left being updated, but we also need to update the size of our timer bar. So what I'm going to do is I'm going to go back into the drawing. I'm going to make some modifications to this. So what I will change here is the bar width. I have my bar width using my time left over the maximum time. And let's try it out and see if that works. Okay, so we have our timer bar here ticking down, being updated every 0.1 seconds. It looks good. It looks good so far. Now I'm just going to draw one more set of rectangles there. This is going to be the background graphic for my timer bar. Okay, let's see if the background works. I'm going to test it out again. Okay, so I have a timer bar with a black rectangle for the background, and you can see it ticking down. Okay, so we have 30 seconds to collect stars, and I don't want the game to just end like that, so I'm going to add in the star when I collect my star. I also want to increase my time. So I'm going to increase my time, so let's just set the time left. Increase my time by, let's say, time left plus the increment. Okay, so when I collect the star, it should increase my time by 0.1 seconds. Okay, my timer bar is ticking down. I'm going to collect the star. So you should see it increase by 0.1 seconds. Okay, maybe that's too short. I'll just set that to 1 and test it out and see if that works better. Time left plus 1. So collect the star. Okay, that value seems to work better than the 0.1 value. Okay, so the game keeps running until you run out of time. So we have to collect stars, and our timer decrease over time and increases again whenever we collect a star. All right, I'm just going to wait for the time to run out and see if our page transition runs, our scene transition. It should fade out. It should kill the actor when time runs out, and the whole thing fades out. All right. Okay, we haven't completed our code yet. I'm going to go back into our game scene and just wrap up with fixing up the transitions. Okay, I'm going to go into the when created event. Firstly, I'm going to set another if condition. Now there is a problem when you try to update the scene, okay, as it's transitioning. So we need to be able to disable our interval counter when our scene is transitioning or fading out. So I'm going to add a scene transition behavior here. Okay, here we go. If the scene is transitioning, let's add in a time and we cancel it out. All right, so we're canceling it out and we should not have that bug appearing again. Yeah, I'm just going to set my max time to 10 seconds so that we can speed this up. Okay, there we go. We fixed that bug and it works fine now. So we basically have a game that runs. The only thing left is to add a couple of sounds. So I'm going to add my collect sound and my music sound. Let's start with the sound effects for the background music. So here we have sound, right? Play sound. I'm going to choose the music. This is my background music, and I'm going to set it to loop. So looping will loop the music endlessly. Okay, I'm using the wrong code block. So I'm going to use the channel attribute because I want to fade in and fade out my music. So just set it to channel 1. I'm going to fade in that sound. So fade in channel 1 over 1 second. So I'm looping my music on channel 1, and I'm going to fade in my sound effect. So it starts from no sound, the volume is set to 0, and it increases until maximum volume over 1 second. Now I'm going to add a fade out. So when we actually lose the game, we are going to fade out the sound as well. Sound channel 1 and 0.5 seconds to fade out. Okay, let's try and see if that works. Okay, our music is in. Not the nicest sounding background music, but it's working. One final sound effect. When we collect the star, I want to trigger the sound effect as well. So here I am in my star. Okay, now there is one more condition that I left out. I need to check and see if I have collected more stars than the maximum time. So if the amount of time that is already exceeded the maximum, I don't want the player to be allowed to collect more than the maximum time. So I'm going to set the condition if time left is more than the maximum time. I will cap that. So set the time left to max time. So this will stop the player from collecting more than 30 seconds, which is or rather 10 seconds, which is the maximum time that I've currently set. Now let's play the sound. Play sound. Right, let me choose the sound to play, and here's the collect sound. Okay. So it should work every time you collect the star, you play the sound effect. Okay, so there we have it. We have a fully functional game, though a very simple mini game, and just about an hour taken to create the game. So it's actually quite quick if you wish to create a game, and this is what I would consider as a very good, quick, rapid prototyping for game development. So within an hour, we actually managed to get a game up. And before this, I've actually took about 2 hours to actually prepare for the mini demo. And 2 hours is actually a fairly short time as well. So if you're considering using Stencyl as a prototyping tool, you can actually mock up a very quick and simple prototype easily in a couple of hours or even an entire day. So as you saw how the demo was run, it only took me about an hour to get it up and working. A total of actually 2 hours for me to test it out and to make sure I fix the bugs before I actually showed the demo. Right, so what's next after this? Going back again, just to let you know. Now this is only for a limited time. Right, this is for a limited time. If you are interested to sign up for this, okay, you will learn the 2 games that I showed earlier on in the preview. Okay, and I'm just going to show you again how much it costs. Okay, registration fee. Now, normally it costs $499 to sign up for this 2-month course. But I'm offering this course now as a special preview promo. It's going to be 200 off, and it's going to be $299 for the entire course that runs for 8 weeks. What's going to happen is if you sign up for this, here's the URL again for signing up. If you sign up for this, uh, you will be invited to a special private Google community where all the training and the tutorials will be uploaded, and you'll be free to ask questions, to post on some ideas that you want to work on. And during the 2 months or the 8 weeks that we'll be building the 2 tutorials, what's going to happen is I would like you, if you're participating, to actually come up with your own ideas based on what you've learned. And I hope that once you have done with your own games based on the tutorials, you'll be able to post it up, perhaps on Stencyl itself, or perhaps on one of the game portals. So I'm just going to wrap up the session now. You can find me again, or the details again at my website, zigchan.com. So if you'd like to find out more details, or you want to know the outline once again, visit the website zigchan.com. Okay, so that ends the preview for today. Feel free to leave a comment or a question in the event page, and I will answer you as prompt as possible. Thank you so much for joining me, and I hope to see you when the course starts. Thank you, and have a good day.